Hi, this is Karsten Evans, and I'll be showing you my smart doorbell setup for remote sensing. Here's my Raspberry Pi setup. The camera is mounted on my kitchen counter, aimed at this front door, so it will be able to tell when people enter and leave my apartment. It's also set up so that when this fridge door opens, it will not trigger the smart doorbell. One flaw my setup has is that it can sometimes detect me entering the kitchen, and that is because the two images it takes are 1 second apart, and usually if I walk just right past it, I will not get a detection because that's less than 1 second. But if the image just happens to be taken 1 second where I'm not on and the next second where I am on the frame, it will send me a message. Now I'm going to show my smart doorbell in action. So I'm going to pretend I'm leaving my apartment right now. So after the demonstration, I received an email telling me the time and day the detection occurred, and it also sent me 6 images. So the first 2 here are the 2 images it took in the time lapse, and then with those the smart doorbell shrunk the image, masked it, blurred it, and grayscaled it, and with that it saw the difference in the pixels here and determined that somebody was there, and so it notified me and recorded a video. This polygonal mask I made was to cover up the fridge door when it is open. I use this shape because it covers up the handle of the fridge when it's open. And it also sent me a text. So this is what I received on my phone at 9:20, and it also sent me a video on Dropbox at 9:20. The video was recorded slightly after the detection occurred. That's why I was already outside, but you see I entered like I did in my demonstration. To give you a quick run through of my Python code for the smart doorbell to work, I first imported all the necessary packages for this project, and then I created a function to mask the image sent into it, so it puts a polygon to cover the fridge that could possibly be opened at any point, and then it will resize the image to make it a quicker calculation by the Pi. It makes the image into grayscale to determine darkness of the pixels rather than colors, and then I blur the image to get rid of a lot of the noise that the camera will return. So the main code will run in a loop, because usually it will not detect anything. So every time this loop occurs, it will take a time-lapsed picture, so the beginning of 1 second and end of 1 second. It will take one picture each, and it will compare those 2 images. For my particular setup, I had to rotate the camera 90 degrees, which is accounted for here. So it compares every pixel of the 2 images, and if the darkness of a pixel in one spot on the image is different by 50, which between 0 and 255, it's different by 50, in the same location on the second image, it will detect it in the detector total. And if there is enough pixels that are different, here I have greater than 30,000, to account for small movements or more noise, then the detection occurs. If the detection occurs, that's when it will take a 15-second video, upload it to Dropbox, email it to me using the simple mail transfer protocol, and then text it to me with Twilio.